You're welcome to today's class again. And we've talked in our previous classes. We've looked at Fourier series. We looked at Laplace transform. Today, let's look at permutation and combination. Permutation and combination. Please, everyone, pay attention because we're going to be doing some classwork in on this page. We're going to be doing some classwork and we are submitting it. This is not going to be an assignment. We're going to do some classwork. So if you pay attention and you listen carefully, you get all I am saying. You get all I am saying. So please, let's do that. It is very, very important we do that. So now permutation. Now by way of definition, let's quickly look at some definitions. Permutations are the different ways in which a collection of items can be arranged. Permutation, I said, are different ways in which a collection of items can be arranged. Permutation, I say again, that it is different ways in which a collection of items can be arranged. Now, in another one, in mathematics, permutation talks about arrangement of all the numbers of a set in some order or sequence. In mathematics, permutation talks about or refers to the arrangement of the numbers of a set in some order or sequence. While combination does not regard order as a parameter, it is just a way of selecting items from a set of collections. That is, combination does not regard arrangement of numbers as a set of parameters or as parameters. So that is combination. Now let's look for example. If we check for example, look at it. Now you have, I said, the different ways in which the alphabets, you can look at, we have alphabet A, B, and C. Now we can group them in different ways. Now how many ways can we group this alphabet? Now A, B, C, how can we group them? Now let's look at, we say, okay, A, B, C, that is one. And we can also say A, C, B, that is another. And we can also say BCA. We can also arrange it as CBA, CAB, or BAC. So these are various ways in which we can arrange them. But one thing I want you to know is that for the fact that ABC I was arranged to CBA does not mean they are the same thing. They are not the same thing at all. Now, just like for the fact that your name is John and your friend's name is John does not mean both of you are the same thing. No, both of you are two different things. Do we get it? So that is exactly what it is. Yes, both of you are human, but you don't have the same thinking. You don't have the same plans. So that is what I'm saying here. It can be arranged the same way, it can be arranged differently, and just when you bring them together does not mean they mean the same thing. Please, they are different things since they are arranged differently. The number, please move to slide 3, please. The number of ways in which n things can be arranged, taking all as at a time. You can, for the formula you see here, we have subscript p, superscript p, np of n equals to n factorial. Then n factorial, that's mark there identifies factorial. It identifies factorial. Now, what is factorial? Factorial of a number n is defined as the product of all the numbers from n to 1. Factorial of a number n is defined as the product of all the numbers from n to 1. So this is factorial. So let's move ahead so that we'll quickly solve some examples. Now let's look at the next slide, the example we have. Question 1 there, he said the question 1 say evaluate 1 12p2 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 and question 2 of it, or rather b 10c3. Now let's look at the solution. If you look at the solution here, we are given n is equal to 12 and r is equal to 2 from the formula. If you could get it from the formula, so And then when you go by computation, you impute the values, you have this. So if you try it, you have this. Now some of us will want to be surprised that how did we get this one? Now let's look at, for example, let's take the number one, the first solution there, 12 factorial. Now 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 1. That gives you 12 factorial. So if you add it, then all over 12 minus 2 of factorial. Now 12 minus 2, what would that give you? 12 minus 2 will give you 10. So the 10 factorial, if you do it the same way I did it, you will have it, then multiply all together, then divide by the denominator, and you get 132. So the same thing applies when it comes to the other question, 10 combination 3 or 10C3. Now you just have to, like, n is 10 and r is 3. So when you impute the values, you get 120. So don't be confused yet. As we go on, you get to understand them like that. The way we go, you get to understand them. Now let's go by a more definition. Now if you see, I said permutation formula is the choice of arrow things from a set of n things without replacement. Other matters in permutation. So if you see the formula I have on the next slide here, you see that this was exactly what we used in solving the examples that we saw earlier. Then a combination formula is the choice of arrow thing from a set of n things without replacement. Others does not matter in combination. Others does not matter in combination, but in permutation, others matter. The arrangement others matter. So you see the formula there. You see the formula there, then n combination r is equals n factorial all over bracket open n minus 1 minus r factorial, which is equals apr all over r factorial. So we'll be using these formulas to solve as time goes on. Thank you there. Now let's look at another example. On the next slide, let's look at the example, the factorial of 5. Now look at this so that you not be confused. The factorial of 5 is what? 5 times 4 times 3 times 2 times 1. So if you multiply all together, what will it give you? Sorry, I cannot unmute. I would have loved asking question, unmuting you guys so that I'll hear your voices, but I'm not worried. Before the end of this training, I think I'll get to hear all our voices. So this is uh, the factorial of 5. Now, the number of ways in which three letters can be arranged, taking all at a time, is 3 factorial. And if you go by 3 factorial, then if you go the way we solved the first 5 factorial, you'll be able to get that yes, it can be rearranged in 6 ways. It can be rearranged in 6 ways. The number of permutation of anything taking arrow at a time denotes by this formula you are seeing, which we have been using subsequently, which we'll be using and will also be using it in time to come. Now, the different ways in which 3 letters taking 2 at a time can be arranged. Now, let's look at using this formula now to solve this other equation. The different ways in which 3 letters, you have 3 letters and 2 are taken at a time, can be arranged as how can we arrange it? Now, if you look at the formula, in the place of n, you put 3 there. In the place of n, you put 3, and in the place of r, you put 2. So when you go there, you now find that you have 3 factorial all over 1 factorial. So when you do your multiplication, you get your answer as 6 ways. You get your answer as 6 ways. Now, let's take note of important permutation formulas. 1 factorial is 1. 0 factorial is 1. Please take note. Now let's solve another problem, because we're going to be solving lots of problems here. And find the number of words with or without meaning that can be formed with the letters of the word chair. Find the number of words with or without meaning that can be formed with the letters of the word chair. Now, this solution, we're going to use permutation to solve this solution. So, how do we look at it? Now, if you look very carefully, please, if you look very carefully, you find that chair has five five letters. If you spell it, it has five letters. So that five letters is equal to 5 factorial. Now, when you solve it according to using the factorial symbol, or the factorial formula, you find that we have 120. We have 120. So that is what it gives to us. Then the different sections possible from collection of items are called combination. For example, the different selection possible from the alphabet A, B, C, taking two at a time, are A, B, B, C, and C, A. So I just want us to know this. And for combination, here is our formula. It's n c r is equal to n factorial all over r factorial multiplied by bracket open and close n minus r factorial. So these are the formulas we'll be using. Please don't be confused, and let us also take from important combination formulas. n n superscript n c subscript n is 1, and subscript 0 is 1, and 1 is n. So let's solve some solutions here. Let's solve some solution. Okay. Among a set of 5 black balls, please listen. Among a set of 5 black balls and 3 red balls, how many selection of 5 balls can be made such that at least 3 of them are blacks? Among a set of 5 black balls and 3 red balls, how many selection of 5 balls can be made such that at least 3 of them are blacks? So how do we go about that? Now we already know, if we bring in our formula, selecting at least 3 black balls from a set of 5 black balls is a total selection of 5 balls. This can be done by 3 Bs and 2 arrows, um, 4 Bs and 1 arrow, 5 Bs and 0 arrow balls. So among our solution now, if we can express our solution as 5 combination 3 multiplied by 3 combination 2 plus 3 combination 4 multiplied by 3 combination 2 plus 5 combination 5 multiplied by 3 combination 0, and this gives us 46 ways in which we can pick at least um 5 black balls. We can pick at least 3 of them. So this is exactly what we were able to get. So if you follow this, we'll be able to achieve something greater later. Then the next one we'll be looking at here is how many 4-digit numbers are divisible by 10 can be formed from the number 3, 5, 7, 8, 9, 0, such that no number repeats. So how many 4 digits can be formed from these numbers? How many 4 digits? Now let's try, before you see the slide, let's try and think how many can be formed on this. So let me give you that as okay, let me know, because we'll have classwork. So let's just continue. Now, for if you look at it, a number is divisible by 10. Its unit places should remain as 0. After 0 is placed in the unit place, the tens place can be filled with any of the other 5 digits. Please just try to get along with me. Selecting one digit out of 5 digits can be done in 5 combination 4, which is 5 ways. After filling the 10 place, we are left with 4 digits. Selecting one digit out of 4 digits can be done in 4 combination 1, which is 4 ways. So after filling the 100th place, the 1000th place can be filled in 3 combination 1, and that is 3 ways. So therefore, the total combination possible is 5 multiplied by 4 multiplied by 3, then that gives us 60. That gives us 60. Okay, now let's look at this. Find the number of words with or without meaning that can be formed with the letters of the word Nigeria. Nigeria. So Nigeria, what are find the number of words with or without meaning that can be formed with the letters of the word Nigeria. Now, if you remember, if you recall how we solved the chair question, so you can use that idea also to solve this one. You can use that idea also to solve this one. So what do we go? The word Nigeria contains 7 letters, and I comes twice. In Nigeria, we have two I's. I came twice in the spelling of Nigeria. So when a letter occurs more than one in a word, we divide the factorial of the number of all letters in the word by the number of occurrence of each letter. So therefore, the number of words formed by Nigeria now is 7 factorial all over 2 factorial. So if you solve it by the way of 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 2 1 all over 2 multiplied by 1, it gives you 2520 or 2520. So these are, please let's try and follow up these examples. I'm bringing them to us so that when we see them, it won't look new to us. We've been seeing them and we can work on them. You can play with them. Use your name. Solve. Use your name. Put your name in place of Nigeria and try to solve out the solution and see what you can get. Or use anything. Just familiarize yourself with it. Now let's take another example. This is funny, but you just still have to get it. How many different words can be formed with the letter of the word super, such that the vowels always come together? How many different words can be formed with the letters of the word super, such that the vowels always come together? Now, if you look at it, super contains 5 letters. Yes, if you spell it, it has 5 letters. But in order to find the number of permutations that can be formed where the two vowels U and E came together, so you could super, super. So this is where the two vowels come together. So all we just need to do is we put everything together. Therefore, the number of ways is 4 letters. So U and E automatically they became one. And when if you look at it, we now have SPRE. So or RUE in brackets. So we take them as one. So now in this case, we have 4 letters instead of 5, and this can be arranged as 4 factorial. The total number of ways in which the letters of the super can be arranged such that the vowels are always together are 4 factorial multiplied by 2 factorial. Now you might want to ask, where did we get that 2 came from? Now the U and E are 2 letters, so we take them as one in the first place, and here we are um multiplying them with the rest, and it gives us 48 ways. 48 ways. So now let's look at some derivations, and let's look at some derivations, or let's talk on some derivations. Now, so now the number of permutation of different things taking R at a time is here. You can see them on our screen. For the sake of our time, let's try to run and do some things, and let's go to let's see this other one. When you look at it, when we now have when you multiply the numerator and the denominator, then you have n minus r n minus r minus 1, and which is 3 multiplied by 2 multiplied by 1, and we get the formula you are seeing on slide 16. So I promised, I said I want to give us classwork to do. I want to give us classwork, and we do not have much time, but anyhow, we're still going to take our class work together. Please, let's just try and attempt this classwork, and as it's going to be on the screen now. But before then, let me take this last example. Let me take this last example before then, because I actually prepared lots of examples. Slide 20. In so many ways can a five, in how many ways, sorry, can a group of 5 men and 2 women be made out of a total of 7 men and 3 women? Slide 20, slide 20, please. In how many ways can a group of 5 men and 2 women be made out of a total of 7 men and 3 women? Now, if you look at my solution, slide 20, please. If you look at the solution, we need to select 5 men from 7 men and 2 women from 3 women. So the number of ways to do this is you bring the formula, then n combination r is equals n combination um n minus r. So when you input the formula, we now have what you are seeing here. So 7 combination 7 minus 5 plus 3 combination 3 minus 2, and that brings us to 7 combination 2 multiplied by 3 combination 1. So if we bring them now, like I told you, combination does not actually follow the arrangement. So we now have 7 multiplied by 6 all over 2 multiplied by 3 times 3. Now, the 7 multiplied by 6 all over 2 multiplied by 1 times 3, and that gives us 63. So please, let's try and go through these examples. They are um, clear and straightforward. They are clear and straightforward. So for the sake of our time, the few time we have, let's look at this classwork. I want everybody to attempt this classwork. Slide 21. Everybody must attempt this classwork and submit to my email before the end of this class. This class is supposed to end by 1:20. Supposed to end by 1:20. So I need everyone submit this assignment on or before 1:20. Anything outside 1:20, please don't submit again. So let's go ahead and work on this assignment. I'm still online waiting for you and seeing everything that you are doing. So please submit, and please again submit it to safetybliss at yahoo.com. Some of you are submitting to a different email. I will not treat it. Let's follow instruction. All assignment I'm giving should be submitted to safetybliss at yahoo.com. I spell the safety SAFETYBLISS at yahoo.com. Safetybliss at yahoo.com. So I wish you good luck in the try for these examples. They are straightforward. This classwork, they are straightforward. They are just a replica of what we just discussed. So I just want you to try it and see how best you can do it. Thank you and God bless you. As I wait for you before, since we still have time, thank you very much.
At least he coming back here.
So how many of us have submitted? I'm checking my mail now.